All right, guys, we are now beginning chapter 6. And as we're going through these chapters, like, wow, the end is getting near. We'll cover chapter 6. We'll cover chapter 7. Not sure if we'll get into chapter 8 or not. So time is kind of running out on us. So chapter 6, it's a brand new start again. A lot of these chapters, when they start, they're not too bad. It starts out kind of easy, and then it kind of builds into things that are trickier. And I think you'll find that with this chapter also. Today's section, I think you'll find, it's pretty easy. Except for the end, we got a couple of things tricky. But then don't worry, it will build into things in section 2 or section 3 that get a little trickier. Okay, so we're going to start with just a reminder, the inverse trig functions. And the way you show the inverse trig functions is you put this little -1 up here. So you have the sine inverse or the cosine inverse or the tangent inverse. And I'll admit that notation is a little confusing. I didn't invent it anyway, but it's a little confusing. And the notation we used to use a long time ago is we'd call it the arc sign. So sometimes the book will use this still, or arc cosine or arc tangent, and it means the same thing as the inverse. Okay, first point, very, very important. An inverse is different than a reciprocal. So when I say the sine inverse, if you're thinking cosecant, you're thinking incorrectly. They are not related to each other. All right? So inverses are different than reciprocals. So the sine inverse is not related to cosecant at all, nor is cosine inverse related to secant, or tangent inverse is not related to cotangent. So they're not related to each other. Instead, what is the relationship with an inverse function? And the answer is it goes backwards. So if I asked you the sine of pi 6, or if you're not so good with radians, if I said, what's the sine of 30 degrees? You'd look that up in your chart and say, oh, the sine of 30 degrees is 1/2. So an inverse trig, so what a regular trig function does is you give it an angle, could be in degrees or radians, and you end with a number for sine or cosine that's between -1 and 1. With the inverse, we just reverse the process. You begin with the number between -1 and 1 for sine or cosine. So what's the sine inverse of 1/2? And it gives out the angle. So you'd say pi 6, or if you're in degrees, you'd say 30 degrees. So an inverse trig function gives you an angle for an answer. You might remember doing this in chapter 2 or chapter 3. We're solving triangles. When you were looking for the angle, they gave you the side, you're looking for the angle. We use these inverse trig functions already. It's always nice in math to loop back and see things a second time and then kind of deepen your understanding of it. So an inverse trig function gives you an angle for an answer. You put a number in there, and you get an angle out for an answer. Unlike your regular trig functions, you put in angles. What's the sine of 30 degrees? What's the sine of 45 degrees? The inverse, you put in the number. What's the sine inverse of square root of 3/2? And you give back the answer, 60 degrees. Okay, so let's practice this a little bit. And we've got all sorts here. It's kind of daunting. You might want to look at the very last page in your packet, see if I can ever get there. And it's got a unit circle in there just to remind you of it again. And we've got, remember, x coordinates are cosine, y coordinates are sine. We've got these listed here. Tangents, maybe we want to list. For 30 degrees, it's square root of 3/3. For 45, it's 1. And for 60, it's square root of 3. We might want to have those as well. And when we're dealing with positive numbers, we're going to deal strictly with the first quadrant. So you can kind of drop off 3/4 of this unit circle. So you can refer back to this as we're doing these problems. And there'll be a few tricks involved in this as well, but it's not too bad. So first question. What's the sine inverse of the square root of 3/2? Well, sine, if you look at your unit circle, that was the y coordinate. I should maybe not put that so far back, should I? The y coordinate, where's the y coordinate? The square root of 3/2. Oh, look, right here. So I give my answer as an angle. I say either in degrees, 60 degrees, or in radians, I'll say pi thirds radians. All right, and I won't keep scrolling back and forth. You certainly can if you're not so familiar with this. But the sine inverse of the square root of 3/2, you'll say 60 degrees, or if you're in radians, you'll say pi thirds radians. And we'll have to look in the book and see which one it asks for. At this point, you should be pretty good converting with either, with degrees or radians. Next one, sine inverse of 0. I want an angle for an answer. Where's my y coordinate 0? That angle would be 0. That could be degrees or radians. Next one, The sine inverse of pi halves. And I said I wouldn't keep flipping back and forth, and now I'm going to anyway. Where does the sine equal pi halves? I'm looking at my y-coordinates. I don't see any pi halves here. I see a 0, a half, root 2 over 2, root 3 over 2, and a 1. So look out for tricks. You're not supposed to put an angle in there. You're supposed to put a number in there. And since this number happens to be greater than 1, this makes no sense at all. If it had been less than 1, we could have figured something out. With the sine inverse of pi halves, it does not exist. It makes no sense. And just trying to fool you a little bit. And hopefully, if you got fooled, just clarifying. Inverse trig functions, you put in a number. You give an angle for the answer. You don't put in an angle. All right, where was the sine 1? Y-coordinate was 1. You'd say 90 degrees. Or in radians, pi halves radians. Not so bad. Let's write cosines. Cosine inverse of root 2 over 2. What angle was that? We're looking at the x-coordinates now. Root 2 over 2. Look back in your chart. Did you see 45 degrees? Or pi fourths radians? Where was the cosine 1? Cosine was the x-coordinate. Guys, that was at 0 degrees or 0 radians. Not so bad. Where was the tangent 1? Look back in your chart. We wrote those on there. That was at 45 degrees. Or you could say pi fourths radians. And again, use that unit circle as a reference as you get comfortable with these, to help you get comfortable with these. Next one, tangent inverse of root 3. That was 60 degrees. Or pi thirds radians. And then just to trip you up a little bit, the cosecant inverse of 2. Let's see, the cosecant is the reciprocal of sine. So this is the same thing as asking, what's the sine inverse of the reciprocal? So what's the sine inverse of a half? So I take the reciprocal of both parts. Cosecant, the reciprocal is sine. 2, the reciprocal is a half. And where's the sine equal to a half? Sine is a y-coordinate. Are you guys looking at 30 degrees? Or pi 6 radians. Last two. Secant inverse. So again, I'll take the reciprocal. Secant inverse, that's a cosine inverse. Oops, cosine inverse. I'll take this reciprocal, and that doesn't look like anything in my chart. But I'll rationalize it. I'll multiply it by square root of 3 over square root of 3. And let's see, I get 3 root 3 over 2 times 3, because root 3 times root 3 is 3. Oh, look, the 3's cancel out. And this is really the cosine inverse of the square root of 3 over 2. Cosine is the x-coordinate. Where is the x-coordinate square root of 3 over 2? 30 degrees, or pi 6 radians. Last one, cotangent inverse. Well, I'll take the reciprocal. I'll do a tangent inverse. I'll take a reciprocal, 3 over root 3. I'll rationalize it. I've got root 3 over root 3. I've got 3 root 3 over 3. Oh, the 3's cancel out. Because again, look, root 3 times root 3 is just 3. So where was the tangent root 3? 60 degrees. Or pi thirds radians. All right, that is our first idea. Hopefully you're looking at that saying, this makes good sense. Hopefully you're also wondering, how do I get into the second or third or fourth quadrant? We will get there, and that will be on the second video, but that takes care of the first one.